Welcome to qnawire.
So we have a population here of size 400,000 and we want 90% confidence. So alpha is 10% and we want a margin of error equal to 0.03. We can assume that our standard deviation for the population is 0.5. And now we want to know the sample size n that we need. So the margin of error is equal to z alpha over 2 times sigma over the square root of n. So if we want to solve this for n, we multiply both sides by the square root of n and divide both sides by the margin of error. That gives me the equation the square root of n is equal to z alpha over 2 times sigma over the margin of error. But I want n, so that is going to be everything squared. So here then I need n is equal to the z with, let's see, z alpha over 2 is the z value with 0.05, which is 1.645. So this is going to be 1.645, my z value, times sigma, which is 0.5, divided by the margin of error, which we're given is 0.03. And then we square that, and we get 1.645 times 0.5 divided by 0.03 equals, quantity squared equals 751.7, but we need to round this to the nearest integer above that, so that is equal to 752. So your required sample size is 752. And I guess that was question 4. Then for question 5, we want to find a sample size n so that we have 95% confidence, which means alpha is 5% and z alpha over 2 is the z value with 0.025, which is 1.96, and the max error here, max margin of error, has to be less than or equal to 5, and we can assume that the population variance sigma squared is equal to 400. Well, now we get n is z alpha over 2 times sigma divided by the margin of error, quantity squared, is going to be 1.96. If sigma squared is 400, then sigma is the square root of 400, which is 20. So this is 196 times 20 divided by the margin of error, which has to be 5 or less, quantity squared. So this is going to be 1.96 times 20 divided by 5 equals, quantity squared equals 61.46, and that means that the integer above that is our minimum sample size, and has to be 62.